Hello everybody, my name is Eric Chi, and I'm a software engineer here at Datadog. And today I'll be sharing with you how we built next generation temporal tooling with worker reflection. To start, we'll talk about how temporal is used at Datadog before discussing tooling ergonomics when interacting with temporal. We will then take a look at the next generation temporal tooling we built and how it improves the user experience before walking through how it was accomplished and exploring areas for further improvement. Now, let us begin with how we use temporal here at Datadog. To start, we built our deployment system on top of temporal, and this quickly expanded to a number of other use cases, including automating the lifecycle of infrastructures like Kubernetes, creating control planes to allow self-service onboarding to internally managed services, and automating complex operations around stateful systems and databases like Kafka, Cassandra, and Postgres. Temporal is also leveraged to build the backends for developer tooling, including a merge queue and incident response follow-up. Here at Datadog, we've been running Temporal for about 3 years now, and currently we execute over 150 million workflow executions in a month across about 1,000 different workflow types, which are owned by dozens of teams. As a result, over 1,000 engineers interact with Temporal workflows every month. For some of you, this diagram may look familiar, as it was originally from Jacob Legrand's talk at Replay 2022. And to briefly recap, at Datadog, we provide a development SDK on top of Temporal, which in addition to allow us to standardize things such as deployments, observability, and auth, provides the core Temporal enablement team more control over things like worker registration, workflow replays, and other aspects of how the Temporal SDK is used. This development platform is centered around our Protobuf SDK, in which users can define their workers' workflows, activities, signals, and queries as RPCs. There are a couple ways that this approach benefits the user experience. Firstly, the development cycle is nearly the same as gRPC, which many are already familiar with. And because service owners must define the workflows, activities, signals, and queries in Protobuf, we have a source of truth for our workers' capabilities. Furthermore, service owners are able to set the default workflow and activity start options, as these are best determined by implementation details most of the time, rather than the caller. For example, this is a snippet proto workflow definition of a workflow that tracks the lifecycle of a virtual pet dog. The dog workflow has a default parent close policy of abandon, a timeout of 30 days, and has some signals and queries which are also defined in the protobuf. One of each are shown in the snippet. And from this definition, we can generate our worker framework code, type-safe clients, and documentation. In order to drive the adoption of Temporal across Datadog, it was important for us to provide an ergonomic user experience, not only for creating and operating temporal workers, but also for interacting with workers and their workflow executions. To start, we will look at the user journey of starting a temporal workflow execution from the Temporal CLI. First, we need to provide the connection parameters to connect to Temporal. And then we need to specify the namespace, task queue, workflow type, and of the workflow that we wish to start. Next, we want to start the default start options. And since we want to use the default value set by the workflow's owner, we can get them from the workflow's protobuf definition. And finally, we need to provide the workflow's input, which we can do as JSON payload. Now, this is a lot of information that users need to collect and provide, and doing so accurately can be quite challenging, especially for new users who are not familiar with Temporal. Thus, we want to improve the user experience, which we can do through better cognitive ergonomics, which we can define as understanding the behavior of humans as they interact with machines or systems like Temporal in order to define interfaces and controls to support their needs by reducing their cognitive burden and promoting awareness of their operations. So how do we apply this to the CLI experience? Well, the first way we can achieve this is by inferring required information. Instead of users explicitly having to pass in all the required information as parameters, can we infer them based on other values? In reducing the amount of information the user needs to provide directly reduces the opportunities for error to occur. The environment manager built into the Temporal CLI is a good example of this. It enables users to emit connection parameters that can be inferred based on the environment flag. Next, we want to have comprehensive input validation. It is not obvious why a command does not work as expected, and this can be a very frustrating user experience. As an example, this workflow start command will indeed start a workflow execution, but it will get stuck and not progress. Because in this case, we have a typo in the workflow type, resulting in execution being created for a workflow type that does not exist. And there are plenty of other similar errors that can occur. For example, we could have just as easily scheduled a workflow into a task queue that has no workers, or provided an invalid input payload. Finally, we want to reduce the proximity of required information by providing contextual help. Ideally, our users should be provided with enough information such that they can determine the desired input parameters without needing to look up additional information from other sources such as documentation or a worker's implementation. And in a CLI tool, this can be done through auto-completion. However, to make these improvements, we need more contextual information, such as the task queues on a namespace, the workflow and activity types on a task queue, and details such as argument types or default start options. And much of this information is not available at runtime to the Temporal CLI, as the Temporal server is largely agnostic to the implementation detail of any given worker. And as a result, many of our users started creating custom CLI tools and scripts to interact with our workflows, thus fragmenting the tooling ecosystem used to interact with Temporal. And this introduced a bunch of problems, such as duplication of work and user overchoice, as many of these tools had overlapping functionality. It is also a challenge to maintain and distribute these tools across hundreds of developer machines, especially because these tools need to be manually updated to reflect any changes made to a worker. And even if these tools are always updated and redistributed in a timely manner, issues can still arise from mismatched versioning. Let's look, for a clear example of this problem. Here we have an example of a V1 of a Temporal worker and a CLI client. Now let's say we deployed updated version of this worker, which adds, modifies some workflow definitions, adds some new workflow and signal types, as well as changing some input parameters. The existing CLI tool would not be incompatible with these changes. We would need to manually update and redistribute a new version of the tool to be compatible with these changes. But this is not a perfect solution either, because if you have an old version of the worker running in a different environment, there could be compatibility issues with a new tool and old worker. And while this problem may be manageable for narrowly scoped tools with a handful of worker and workflow types, it does not scale well to the 1,000+ engineers who may want to interact with any of the 1,000 or so workflow types here at Datadog. So what we ended up building to address this was a universal Temporal CLI tool, which leveraged contextual information to provide contextual help to the user, infer values based on available information, and validate user input, all without being directly tied to the implementation of any specific worker. So let us look at the improvements that this user experience this tool enables. First, we introduced the concept of a context, which allows users to specify a single namespace on the given cluster with a single parameter. Next, we can infer the workflow start options based on the workflow type to be the default ones defined in protobuf. And this means that users no longer need to specify them unless they wish to override the default values. We also found that many users often perform consecutive operations on a single task queue in a single context. So we allow users to persist the default values between executions. And this simplifies the start input for the same dog workflow to this, which is not bad, but we want anyone to be able to create a new dog easily. And crafting payload JSONs in terminal does not make for a good user experience. Users will likely need to refer back to the message definitions to figure out the data model, and the process is very prone to error. To address this, we can try and generate flags for all top-level requests in the field, but in this case, it doesn't really help much. And looking at the request definition, we can see why. It's because the parameters we want to set are nested in the dog type. Our first approach was to try and recursively generate flags, but this did not scale well, as the number of flags could be too numerous with even a small number of repeated or nested structures, and can even balloon to infinity if we have recursively nested structures. And not all parameters need to be set by the users anyways. Some fields like neediness or happiness could be seeded or set to a default value, while other values here are used to track the state to allow the work to be continued as new, so probably should not be exposed to users at all. So we'll create a wrapper workflow that allows us to create a dog workflow child request, and we'll only have exposed the information that we need from the user, which is a name, and optionally the appetite and neediness. In addition to abstracting unnecessary information, This new dog workflow provides us a lot of flexibility to set default values, perform input transformation validation, or even enrich inputs from data with other sources. For example, if a dog needs a registration number, in this wrapper workflow, we can provision one on behalf of the user and use it to start the child workflow. Now, with this wrapper workflow, we can simplify the command to start the same dog workflow to this, with generated flags for names, appetite, and neediness. And if you need to do some debugging or have a more special use case that's not covered by this wrapper, you can always start the original target workflow directly. To give a better sense of how everything fits together, I put together a short demo. The name Inoichi comes as the idea was inspired by a Tamagotchi, which translates to egg watch, so it becomes dog watch. And the idea was to model the life cycle of a virtual pet as a workflow with the ability to interact with a pet through signals and queries. So to start, we will start up a Temporal Light server and the Inoichi worker. And while it starts up, we can set our default context and task queue. It's good. That's small. Sorry about the size. We can start by inspecting the available workflow types with the workflow types list. And this gives us, of which there are two, the new dog and dog workflows. We can also list the activity types on this worker. And we also have another two, one to simulate eating food and one to simulate going on a walk. And here we can also describe workflow type to learn more about it. In this case, we can describe the dog workflow type. And this reveals a bunch of information about the request and response types of the workflow, as well as the signals to feed and walk the dog and a query to visualize the dog. Now we want to create a virtual dog named Bits with a new dog workflow. And as you'll see, we get auto-completion suggestions for the workflow type on the task queue. And then we're going to get some generated flags based on the workflow type selected. And this starts up the new workflow. And in the trace, you can see that new dog creates a new dog workflow with workflow ID bits, and that and it triggers a 30-second timer. And the way that this dog workflow works is that every 30 seconds, there's a chance your dog may get more hungry or less happy. And to visualize this dog, we can query bits. And here we can see that we get auto-completion of the query type based on the workflow ID provided. And we can wrap the whole thing in a watch so we can see changes to our dog state over time. Now, we want to take Bits out for a walk, and we can do so by sending a signal. And once again, we get auto-completion of signal types based on the workflow ID provided. And we also get generated flags based on the signal type that we specified. So after we send a signal, you can see in the trace that the signal is received and it starts the walk dog activity. Now after the walk, Bits got a bit hungrier, so we can feed the dog with another signal. And this time, we also get auto-completions for valid values of the flag for food type. And once again, after sending this signal, we can see that the signal is received in the trace and it starts the eat food activity. Now, let's start a new version of the worker that adds the ability to play fetch with our dog. and a new activity on the and signal for on the dog workflow to enable this. With the workflow, the new worker started, we can resume our watch of the dog. And without making any changes to the CLI tool, we can see that the new activity type is reflected when we try to list activity types. And we're able to get completions for the new signal that's been added as well. So as shown in this CLI demo, the CLI is able to pick up new additions and modifications to the worker automatically without needing to be updated. And for this to be possible, we needed a way to dynamically retrieve the required contextual information at runtime. And as mentioned earlier, the information is not available from Temporal server. Thus, we need to look elsewhere for inspiration. And thankfully, we didn't have to look far, as the gRPC ecosystem, which is also rooted in protobuf, faces the same challenges we just looked at. But there exist many universal gRPC clients like the gRPC UI and the Evans CLI. But how do they work? Well, under the hood, all these tools rely on gRPC server reflection, which enables us to introspect the gRPC server to answer questions such as what methods are available, what methods does the server export, for what particular method, how do we interact with it, and for a particular message, what are its arguments. And this information is conveyed using protobuf descriptors, in particular file descriptors, which contain the exact information of a .proto file, and these file descriptors can be combined into sets containing all the dependencies for a given service. And because we define our temporal workers in protobuf, we can also leverage reflection with protobuf descriptors through a reflection workflow on every worker. And this allows us to determine a worker's workflows, activities, signals, and queries, and start options directly without directly relying on imported generated code. And because we control worker registration, we're able to determine what a worker's capability on startup are by intercepting the worker registration calls and to populate a workflow reflection registry. We're also able to register the reflection workflow to every worker without user intervention. But there are still more ergonomic challenges that our users face with our tooling. And the first centers around information density. Here's the early example describing the dog workflow, and it presents us with a pretty dense wall of text. And there's simply a practical limit to how much information you can present in a terminal while maintaining readability. The second relates to complex input. While the CLI and dynamic flag generation work great for interactions with simple workflows, there are limits to usability around complex workflows. For example, if we update the dog's definition to be more comprehensive with information such as breed, vaccination, ownership, tricks it can perform, and more, creating a JSON payload can be quite a challenge with all the repeated and nested structures. And a UI is much better suited for managing this type of complexity and will allow for more interactive experiences. Experiences such as a form builder for crafting complex input payloads, and can possibly aggregate all the workflow reflection information into a catalog to provide better visibility discovery for users. Unfortunately, there's no existing proto-reflect library in JavaScript which will allow us to leverage our protobuf descriptor-based implementation of reflection directly. So our solution was to convert these protobuf descriptors to JSON schema. And you can see some of this included in the describe output from earlier. And this can be used in conjunction with tools and libraries from the JSON schema ecosystem to create a form builder for interactive UI experience for interacting with workflows. We're also interested in extending these capabilities to the open source community. While our implementation of worker reflection is centered around protobuf descriptors because our internal temporal development platform is centered around protobuf, The core idea of worker reflection, which is simply the ability for workers to describe their capabilities, is generally applicable to temporal. Protobuf descriptors were simply a convenient interchange format to do so. For non-protobuf-based systems, another format like JSON schema could be used to convey the same information. And thank you for listening.
Thank you. I just want to go play with the, remember those Tamagotchis? Do you remember those? I'm going to date myself. Okay. All I was thinking about was like all the little dogs and feeding them and how I was really about keeping them alive. So anyway, that was what was going through my thought and thinking about all the workflows that might go into that. So with that, does anybody have any questions? And Patrick, you're my mic runner again? Perfect. What questions do we have? I'm back there.
So how do you authenticate against the temporal cluster from the command line? What process do you use?
We have an internal tool that we call under the hood that grabs the auth tokens and it's sort of hidden away from users.
And so they have to do some previous authentication step, or is it just all in the context?
It's all in the context.
All right. Thank you.
When you were able to do this autocomplete of signal names, how does that information get populated from the workflow to your tool?
So how that works is that the CLI tool will start a reflection workflow, and that's registered to every single worker, and that reflection workflow returns back a description of itself, and including all the workflow types, and then from there we can figure out all the signals registered to that workflow type.
Just to confirm, so you send a query over?
We start a workflow execution, and then
and then you query on that one, query on the workflow to get answer of all this information while this autocomplete information show up.
Yeah.
Wow, that's cool.
Did you ever consider going the other way and ripping the actual definition of the worker and using like normal Go reflection stuff in order to try to rip out like what does the request look like? What do the signals that the could take? Did you investigate that approach?
We have not investigated that because we use the schema first approach of protobuf, but I'm pretty sure it would be possible with JSON schema, especially the libraries out there, let you go backwards from Go struct types.
Seems pretty cool. I'd use that any ETA for open sourcing it or not.
I think we want to open the discussion more about with a GitHub issue about like worker introspection in general, but what that would look like is probably not the same as like our Datadog implementation.
Thanks. I just wanted to make one follow-up comment on the question before last, that we also use protobuf to be able to be language agnostic. So we don't want to use language-specific reflection. We want to be able to like self-describe generally across languages.
Was this built for self-hosted tooling, or do you use cloud and you get all this information on reflection with workflows against Temporal Cloud?
We are self-hosted, but this implementation doesn't matter if it's implementation, whether it's self-hosted or cloud.
I guess what I'm asking is, did you fork any of the Temporal services to get this to work?
No, everything is done on the worker side.
Got me thinking about writing a Spring Boot equivalent to basically expose each workflow's reflection and then basically do the same thing. I think we should collaborate on something between us. It'd be pretty awesome.
Any other questions for our lovely speaker? And if you are just so in awe, you're like, I don't even know. There's good news. I bet you can find him somewhere after the conference, maybe at a happy hour, or you can buy him a coffee and say, I want to ask you all the questions. So you still have time. Do you like how I volunteered that?
I'm also on the Temporal Slack. It's
Also on the community Slack, so you don't have to chase him down here at the conference. Okay. I'm going to one more scanning, and let's give him another round of applause. Thank you.